So you have to solve this equation. You had, let's say you had log base 3 of 2x minus 5 is equal to, let's say, 2. Do you remember how you solved this equation?
You got to expand it first, huh?
No?
No.
No, you can't distribute that because that doesn't mean log times, so that's not distributed
You
properly.
got to condense it, right?
You have to remember on that non-calculator part, how'd you go from those log equations to something that you can figure out what it's equal to? You change it to an exponential.
Right.
You change it to an exponential. You have this log equation, you're going to change it to an exponential. Now, when you change an exponential, remember you got to have that log by itself. And what should the coefficient be? 1. So you're going to say 3 squared equals the argument. 3 squared equals the argument, so that's 2x minus 5. And what's 3 squared?
9.
So I have 9 equals 2x minus 5, and so notice this is a linear equation. So all you do is add 5 to both sides and divide by 9, and you're basically done, although you got to do one more thing. So 9 plus 5 is what, 14? And so therefore x would be 7. Okay, now, one thing you got to remember though. Remember, you can only take the log of what kind of number? Right, so the log base b of m, m must be a positive number, right? Okay, so there will be situations where the value you get for x, when you plug it back in, it makes that argument negative. So you got to remember that when you solve log equations, you have to check your proposed solution. You must check the proposed solution. And all you have to do really is just check the argument. You need to make sure that the argument is what kind of number? Positive. So when I plug 7 back in, what's 2 times 7?
14.
And what's 14 minus 5? 9. So that's a positive argument. So we're good. Now you can go further if you want to. You can ask yourself, well, is 3 squared equal to 9? And the answer is what? Yes. You had that on that non-calculator part in that last page today, where you had to use that idea. Okay, now, here's what you're going to see, though, on your final. But it's going to involve this idea. All right, so let's look at this. All right. Let's suppose we had this. Suppose we had log base 6 of x plus 5 plus log base 6 of x equal 2. And that's what we have. Log base 6 of x plus 5 plus log base 6 of x equals 2. Right. No, not that, because it's just a monomial. I mean, it's just one factor. Now, that was like 3x, then yes, you put it in parentheses.
I just listen to when you say I just automatically make that
That's fine. You can put that. You can put that x in parentheses if you want to. It's not needed because it's just an x. If it was a 2x, then I would need that parentheses there because it's 2 factors. Okay, so remember, in order to change a log equation to an exponential, see how we did this? You have to have how many logs on this side? 1. How many logs do I have? 2. But we know a property about this. How can I convert this to one logarithm? Okay, right. Do you remember one of the worksheets? It says rewrite this by condensing. Okay, so the bases are the same, so that means I can write this as one logarithm. And what do I do to those arguments?
You add them?
No, you multiply them. So it's going to be x times x plus 5. All right, so that right here is this. That was one of your worksheets. So you're condensing this sum. So you're writing the sum as one logarithm. Then since this is an addition problem, you're going to do what to those arguments? Multiply them. So x plus 5 is being multiplied by what? X. Right? That's what this looks like. Right? And that's all going to equal what number? 2. Now this looks like this. That looks like this. So you have this log equation. The log is by itself. What's the coefficient in front of log? 1. So now you can change this to an exponential. So how do you do that? 6 squared equal x times x plus 5. Very good. So that's where we're at. Now notice when we did this one, when we did this right here, we ended up with what kind of equation? Linear. What kind of equation is this? Quadratic. That's quadratic. All right. So that's quadratic equation. All right. So we get 36. Now, one of you on the test day that I saw, I didn't look at everybody's, but one of you said x equal 36 and x plus 5 equal 36. Is that true?
No.
No, that's not true. What has to be on this side in order to be say each one equal to that number? What has to be here? 0. 0 has to be there. So no, you can't do that. Okay, but what you need to do is this. You say 36 equal and then distribute, right? So what do I get?
X squared plus 5x.
All right, almost done. Now what kind of equation is this?
Linear.
No. Quadratic. How do you solve it? What form do you want to put this in to be able to solve it? Well, okay, but it's in standard form, right? Which means you got to have what on one side? 0. It's easy if you bring the 36 to the other side. So 36 minus 36 is 0. So I get x squared plus 5x minus 36. Now, the one on your final is factorable. So if you don't remember how to factor this, then don't spend 10 minutes wasting your time trying to factor this when you can't remember. What should you do? Quadratic formula. So and you're given the quadratic formula. It's the opposite of b plus or minus the square root of b squared minus 4ac all over 2a, right? So what's a in this case? 1. What's b in this case? 5. What's c in this case? All right, and all you do is just take these values, plug into your formula. So we get x equal the opposite of b. Well, b is 5, so what's the opposite of 5?
-5.
Plus or minus the square root of 5 squared minus 4 times a times c. Very good. All over
2 times 1.
what? So we deal with the discriminant. Remember the discriminant. So I get -5 plus or minus the square root of, what's 5 squared is 25, right? All right, on your calculator, first of all, a negative times a positive times a negative is a positive.
You said a negative times a positive times a negative. Oh, never mind.
Okay. And what's 4 times 36 in the calculator?
144.
144? All over 2, right? And so what's 25 plus 144? 169? And so 169 is a perfect square, which means that the square root of 169 is just what whole number?
13.
13. So I get -5 plus or minus 13 over 2. And then all I do now is break it apart. -5 plus 13 is what? 8. 8 divided by 2 is 4. Here's how I got the 4, right? -5 plus 13 is 8. 8 divided by 2 is 4. For the next one, you're going to say -5 what? Minus 13 over 2. So that's -18 over 2, which is what? -9. All right. So those are my proposed solutions. So what I'm saying is that x is 4, or x is -9. It can be both of them. It can be one of them, or none of them could work. You have to check it. And all you have to do is just check the argument. Just check the argument. Go back to the original, though. Don't go back to anything else down here. You got to go back to the original. So, for example, let's check 4. What's 4 plus 5?
9.
Is that positive? Yes. This was just an x, right? So my argument here is 4. Is 4 positive? Yes. So 4 is good. 4 is going to be a solution. Let's check -9. What's -9 plus 5? Can I take the log of a negative number? No. You take the log of a negative number to calculate, you can get an error. Now since this one fails, do I have to worry about this one? No, only one of them needs to. So negative 9 is extraneous. You remember what extraneous means? It's a false root, which basically means negative 9 is a solution to one of those equations. Which one is it? This quadratic. But is it a solution to this log? No. All right. So it's the only solution. X equals 4. So on your final, you have one. I'm telling you now, guys, you have one. Don't lose that 10 points. The problems in your final are 10 points each. That's the way they usually do it. 10 points each.
The problems in your final are 10 points each.
10 points each.
Yep.
And what do you get, like 20 of them?
There's about 20 of them. Now, some of them have different parts, just like your test. They have different parts. Okay, so make sure you can do this one, okay?
You gonna put a video on that, what you said?
Yes. Well, actually, there's one already on it. There's a video on this already. Now, what about this one?
Look, I have a question on the one you just did when you went to the 6 squared. How did you get the 6 squared? You had 2 logs.
Look at 6 squared, 6, changing this to an exponential, 6 squared equals the argument.
How'd you get one? Yeah, that's a good question. How'd you get, you had 2 logs, top one, and then you just have one.
I condensed it. The product rule. The product rule.
Same thing. Log 6 and log 6, right?
The bases are the same. So the bases are the same. I can write this as, that was something we
I know.
okay, so it was on a worksheet, but basically when you're taking the sum of 2 logs, you can write it as a multiplication problem, right? If this is subtraction, you need to write it as a what? A division problem. Okay, a quotient. You use the quotient rule there. Okay? All right, look at this one. Suppose you had, all right, let's suppose you had log base 4 of, I lost it. Okay, x plus 2 minus log base 4 of x minus 1 equal 1. Now the one in your finals, it's going to be an addition problem, so you're going to have to change it to what kind of problem? Product. And it is going to be a quadratic you end up with.
How many of these are we gonna have?
100.
I'm sorry.
You're talking about this right here? Just one. Just one.
Exactly. No, how many of these types of problems?
Just one.
Okay.
The worst one's 100 on
I really do.
Okay, so how are you going to write this? Remember, I can't change this to an exponential unless I have how many logs on one side? Just one. Here I have 2. So I've got to change this to what kind of problem? Division. So that's a log base 4. And remember, you're taking the log of a quotient, right? Okay, what's the numerator? X plus 2. What's the denominator? And what does that equal?
1.
All right. Now can I change this to an exponential? Yes, because you have 1 log, and what's that number in front of it? A 1. So if that was a 2, you'd have to divide by 2 first. Okay. So now how do you change this to exponential? 4 to the first. That idea is what you have to use on that last page of your test, the one where I said you couldn't use a calculator. 4 to the first.
Is x plus 2 over x plus x minus 1.
Yeah. And 4 to the first is just what? Now I'm going to write this as 4 over 1 though, just to remind you about something. What?
At some point, we're going to have to
What happened to the what?
The equal 1.
It's right here.
argument.
Oh, okay.
4 to the first. Okay. All right. Now, remember, this is called a proportion. When you have a fraction equal to a fraction, that's called a proportion, and you can cross multiply. That's a proportion. And so you can cross multiply. So I get 4 times what? Minus 1 equal 1 times x plus 2, right? Which is x plus 2.
I'll put it back now.
Yeah.
So can you just explain why we're using proportion here?
Because it's Well, it's a proportion, and remember, one of the things you learned was that a proportion can cross multiply. So when you have a fraction equal to a fraction, it's a proportion, and you can cross multiply. Now, if you want to multiply both sides by the LCD, you can.
I don't want to do that. I don't want to do that. That's okay.
No, but some of you are not going to remember that this is called a proportion. So you get 4 over 1 equal x plus 2 over x minus 1. What's the LCD? X minus 1. So you say times x minus 1 times x minus 1, right? And then the x minus 1s divide out. And so you get 4 times what?
4x
Equals what?
Oh, yeah.
Which is what this is.
I got that.
Okay? So it doesn't matter what approach you take. Did you turn in your worksheets that due today? Where is it? And you leaving already? Okay. All right. And then what kind of equation is this?
Linear.
You're supposed to say till 9. You know that, right? All right. What are you going to do here? Distribute. So what do you get?
4x minus 4.
What kind of equation is this? Linear. So subtract x from both sides. What's 4x minus x? Minus 4 equal 2. What's the next step?
Add 4.
So 3x equal what? 6. So what does x equal? 2. Now remember, this is a log equation. You have to check. You have to check. All you do is go back to the argument. What's 2 plus 2? So we're good. It's positive. What's 2 minus 1? We're good. It's positive. Okay? So that's your solution. All right? Okay, now look at this. All right, listen carefully. You remember your two formulas? A equals P times 1 plus R over N raised to the NT. And the other one, A equals P times E to the RT. All right, listen carefully to this. So this idea you've already had. So listen to what I'm asking you. How would you solve this equation? You've already had this. 6 to the x power equal 4. How would you solve this? How would you solve for x? There's no way you can get the bases to be the same, right?
Right.
So how are you going to deal with this? What did we do last time?
We changed the bases. No.
Get a common factor, but
We took the log of both sides.
Oh, Jesus.
that was like the same 1-to-1 thing.
Nobody
Like
did that.
the 2.
Yeah.
We took the log of both sides. No, there's no way you can get the bases to be 2, guys. 2 to what power is 6? 2 to what whole number is 6? You can't.
There is no 1.
All right. So what you had to do there, remember, was take the natural log of both sides. Remember that? And then y'all need to look at those notes. All right. Look at that. Now, I hadn't posted that video from last class period. I'll try and do this weekend. So what do you do to this x now? Put it in front. That's a power rule. So we get x natural log of 6 equals natural log of 4, correct? Now what? How do you get x by itself? Divide by what?
Natural log of 6.
Natural log of 6. And so x equals natural log of 4 divided by the natural log of 6. Now, approximate this. Come on, guys. We got to work on this. Approximate this. So natural log of 4 divided by the natural log of 6. Because that's going to be important to what we're about to do. So you said natural log of 4 divided by natural log of 6, right? You get 0.7737. If let's just say it's 4 decimal places, 0.7737. Now remember, the idea was to solve this equation. The original was 6 to the x equal 4. All right. Now listen carefully to this. All right. It's not going to be that difficult as long as you remember what we just did. Watch. This is on your final. Poor Jesus heard his name called out 50 times within the last hour.
Sweet baby Jesus. Sweet baby Jesus.
Oh, God. All right. All right. You invest $2,000 at 3.6% for 2.6 years. Okay? So you invest $2,000 at 3.6% for 2.6 years.
That's 3.6%?
3.6, yeah. How long will it take for you to get, let's say, $5,000? $5,000. So you want to go from 2,000 to what? 5,000. So how long will it take? Now, when you hear the phrase "how long," what comes into your mind? What letter? T. Time. T. So you're going to be solving for T. Okay. So listen. So you invest $2,000 at 3.6% for 2.6 years. How long will it take for you to get $5,000 if the interest is compounded quarterly? Quarterly. So if it's remember, quarterly means how many times a year? So that's finite. That's finite. So that means n is what? 4. Okay? So what form am I going to use? Which one of these am I going to use? This one here, right? You use this one when you use what word? Continuous. Continuous. Okay, so watch how simple this is. So A equals P times 1 plus R over N raised to the NT. All right, what is P? Which of these numbers represent P? 2,000. Remember, P means principal or the original amount. Principal or the original amount. What was the original amount? 2,000. A is what you end up with. I would end up with 5,000. So you're going to say 5,000 equals 2,000 times 1 plus R. R is 3.6%, right? But you must write it as a decimal. Very good. 0.036 divided by N, which is what? 4, raised to the 4t. Raised to the 4t. Okay? All right, now, plugging things back in was the easy part. But listen carefully about what I'm telling you to do. You see this parentheses right here? Use your calculator to approximate what that's equal to. So you're going to say 1 plus 0.036 divided by 4 press equal. So you get something like this, right? You see what I did? Okay. Yeah, so I get 5,000 equals 2,000 times 1.009 to the 4t, correct? All right. Now, remember, next thing you got to do is get rid of this coefficient. So right now I'm multiplying this 2,000 by this. I got to get this by itself. So what do I need to do? Divide by 2,000. Watch how simple this is. What's 5,000 divided by 2,000? 5 over 2 or 2.5, is that right? Yeah, because they're both divisible by 1,000, right? 5,000 divided by 5,000 divided by 1,000 is 5. 2,000 divided by 1,000 is 2. But you get 2.5, right? Okay. Equal 1.009 raised to the 4t. Okay, you understand what it did going from here to here? All right, now I want you to compare this with the one we just did.
Does that not go over 2,000 as well?
Huh? Say again?
No, never mind. I'm kidding. You got it.
All right. Now, I want to get t, right? So how do I get t out of the exponent? Take the log of both sides. But let's go you can take the common log or you can take the natural log. It doesn't matter. But if the base was e, you'd use which one?
Natural.
The natural log. Very good. Because the natural log of e is equal to what? 1. That was on that back page. All right. So you take natural log of both sides. So watch carefully, y'all. Natural log, natural log. Now I can do what to this 4t? Yep. So I get the natural log of 2.5 equals 4t times the natural log of 1.009. And last class period, and some of you struggle with this, last class period, I need to get t by itself. So I'm going to have to divide both sides by something. If I'm going to get t by itself, you'll see right now I'm multiplying by 4, right? So I've got to do what? Divide by 4. But I'm also multiplying by what? So I have to do what? Divide by. Okay, so the 4's divide out and the natural logs divide out, so we off with what? Okay, now remember, some of you had struggled with putting this into the calculator. So remember what we did was we said the natural log of 2.5, you could say divide by 4, press equal, and then divide by natural log of 1.009 and then press equal. All right, so watch what I'm doing. Okay, real quick. I know we have a few minutes left, but real quick. You're going to say natural log of 2.5. So the natural log 2.5. Close. You can divide by 4. Press equal. Press equal at this point. Then you're going to take that and divide by what?
I mean, the other one.
Yeah, ln of 1.009. Close the parentheses, and then press equal. Yeah, this not it, the time. No, the time has something wrong here. No, I know the times. Something's wrong with the time.
I got something different, but I deleted it because I thought I got it wrong.
No, did I?
That first part again is
Yeah.
the natural log.
Yeah. So, I want to go from 2,000 to 5,000. So that's 3.6. So that can't be right.
We never did nothing with the 2.6 years.
What?
We never plugged in the 2.6 years, or was that?
No, because we're trying to figure out.
Oh, okay. I'm okay. Yeah. No. I. I never. No. Yeah. That. I'm looking for the time, so I should never have given that one. But let me. There's something. Okay. So.
No, you still were solving for it.
Yeah, I'm still solving for t, so it really didn't matter. 2,000 going. So I'm trying to figure out. Is my calculation correct?
Well, maybe not. You know what you did? You did 0.036. Shouldn't you just 0.36?
No, you gotta do it twice. What's the, to change your percent to a decimal, you 2 times?
Okay. So let's do this. Let's put this in parentheses right here and see if we get the same thing. All right. So say natural log of 2.5. All right. Divide by, then say parentheses 4 natural log of 1.00. Oops. 1.009. Close. Okay. So now that one sounds better. So let me tell you what to do. Okay. So put the best thing to do then is to put this in parentheses. The denominator, put in parentheses. So, and then you're going to say this. You're going to say, make sure you put in parentheses, okay? On your final, make sure you put this in parentheses. All right, so you're going to say natural log of 2.5. I need parentheses here. Divide, parentheses, then divide by, then open parentheses, then say 4 times natural log 1.009. Close that one right here. But you got to close it again, right? And then press equal. And so 25.6 years.
Okay, yeah, because that's what I got.
All right. Well, the interest rate's but the interest rate's pretty low. And then you're more than doubling your money. So you want to more than double your money. So yeah, it's going to take a long time. Okay. All right. So there's the other one that they're going to ask, and there's something posted on this. So on section 4.4, it's video 4. Video 4 does this. Video 4. So there's one on compound interest, and there's one where it says continuous. Okay? All right, so Liz, I think there's some people that left. I'm trying to figure out who they were.
We getting 5%?
No. It's not going to matter to some of you, right?
But it is going to matter to me. What if I
Because
can't write down?
you're retaking that test, so.
We need to talk about that.
Can we just be the only ones that can take it if they say?
What?
And our bonus